So is Q greater than R? Statement 1 tells us that Q times R is 32. There's a lot of different combinations of Q and R that can give us Q times R equals 32, to say nothing of the fact that those numbers can be reversed. So you know, even if you pick 2 and 16, they could also be 16 and 2. So we have no idea about Q's relationship to R. Statement 1 is not sufficient. So we can get rid of statement 1 being sufficient as well as each alone. Statement 2 tells us Q squared is greater than R squared. While that can be true, it doesn't take into account negative numbers. So if we pick, for example, Q equals 16 and R equals 2, Q squared will definitely be greater than R squared, and Q will be greater than R. If we pick Q is equal to negative 16 and R is equal to negative 2, here Q squared will still be greater than R squared because negative 16 squared becomes a positive number and it's the same as 16 squared. So you know, these two sets will be equal in statement 2 because we're squaring a negative number. But in the question of Q minus R, so Q minus R definitely in this one, Q minus R, Q is not Q minus R, I'm sorry. Q being greater than R, definitely with the first set of numbers. Q is definitely not greater than R in the second set of numbers. So when the answer is sometimes yes, sometimes no, again, that statement is insufficient. It's not 2. And again, the fact that we can go to positive or negative numbers, the fact that we can switch around these two values for Q and R in every case, even when we overlap the two domains of the two statements, we aren't able to eliminate any of these problems that lead to multiple values and multiple answers to the question, is Q greater than R? So even in conjunction, the two statements are insufficient. Answer choice E.